Now let's see how our Python program in Raspberry Pi is working. What is assumed is that you have to first install the Mosquito server that is running in the background. And what our Python program is doing, our Python program is receiving messages from the Arduino side, the sensor side, and it's also sending messages to sensor to Arduino. The receiving messages are the temperature and the voltage, and the sended messages are the LED brightness. And also that the Python program is interface between the MQTT send received messages and the web server. And there are two variables that are acting as an interface from that MQTT functionality side to web server side, and these are these two variables there. So the interface between the UIs is quite simple, only two variables there. The software flow in Raspberry Python side is quite simple also. First we initialize these variables and what is needed to doing the setup, and then we will connect to MQTT server, the Mosquito server that is running also in our same Raspberry, that our this Python program, and then we will subscribe to out topic. This means that we are starting to listening to Arduino's messages, which are this out topic. The channel name is out topic in that those channels that are temperature and voltages. And then we will continue to start the web server. This is, let's say that this is the MQTT functionality part, and when that is initialization of that is done, then we start the web server. That we will see next. And there's also callback program. In MQTT side, it's that the callback is called when we will receive these messages from the Arduino. And first we will digging the information from the message. So we'll check that is it the temperature or voltage that Arduino is sending, and then we will build these numbers from the ASCII characters from the message, and then we will print these values that we have received. And if it's voltage that we have received, we will store that value to variable v1, and if it's temperature, that value will be stored to t1. These are the variables that acts as a storage place for those measured value. Let's first look from the code side how this initialization and the start functionality is done. First, there are these libraries that we have to include here. Is this Peiho MQTT client, and then there are some timer functions, and this web server function. This Flask server is the web server functionality. And here are some variables that we are defining here. This is the incoming message, string variable for incoming message, and first we will give some default value for that. This means the empty. And here are these variables for our voltage and the temperature, and we will give some initial value for those variables. And in the beginning of the setup of that program, we will assign event callbacks there. We are using this MQTT as our new parameter or new function there. And here is the code itself that will start. First we will make a connect. We will connect to that our Mosquito server. Here is the local host. It means that it's the Raspberry Pi's local IP number, and this is the port number for that MQTT, and this I guess was some timeout value. And when the connection is done, connection is working, then we will subscribe for this output topic. We define here that again that what topic we are starting to listening. So when the Arduino is sending data to out topic, and then this program will receive those out topic messages. And this 0 here means that quality of service is 0. It means that there is no need to any guarantee that the messages has really received. And here we will start the MQTT loop, and from here we start this web server, this Flask server functionality. So the MQTT functionality ends here, and that from here we start to set up our web server, Flask server. And here's the callback functionality of our Python program. We will when we get the message, we will start to digging out that what is the content of the, what kind of information there are in the message, and print the message and store those values to our interface variables. And here's our Flask server. Site start from here. We define that there are two methods that we could use. We are only using this get method here, but in here it's basically possible to use post and get method. But in this application we are only using this get method. And here we define that our variables, voltage and temperature. And in here, if our browser has request get method, so then we start servicing the get method here. Our user interface program, HTML JavaScript program, is using two parameters to transfer the data between this Python program and the UI, and there are these two parameters. The other one is mode and the other one is date. These are the two parameters that our user interface will transfer to this Python program by using this get method. And first we will print those mode and date, and then we start to check out that what is the mode. Is it the L mode? That L mode stands for LED. It means that control the LED. And the L mode, in L mode there could be two numbers following that L. The date that could be 255. It means the LED on, or it could be 000, means LED off. So there is this mode variable and that variable that are used for communication. And then there's also this P mode. This means the brightness control of the LED. And if the mode was P, then we are building the integer number from next ASCII marks. We will take those ASCII marks that are in the date variable or the date string and build integer number of those ASCII characters. And if we were receiving this L255 from our user interface, then it means that LED on. This means that LED, and we will give this full number to LED. And then we will send this to in-topic channel, which the Arduino is listening this in topic, and we will send this the message that will start from PW, and then there's 255. If you remember, if the Arduino will receive this kind of message, it means that the LED to full power. And if the message was this, then switch off the LED. This MQTT publish will send the MQTT message to Arduino side. And if there is this brightness control, then there was this mode P, and then we will send the same data string to the same in-topic channel, and here's this mesh string that contains the number of the brightness. And here we are building that string that will contain the brightness value from the UI. And then we will return this, inform that everything was okay. The L mode and the P mode were direct commands to that our LED, but we have to also communicate from the other side to UI, and for that we are using this W mode. The W mode is the way to write these temperature and voltage values to our UI, to our JavaScript program, and it's done here. We are using this string G string here, and we are putting in the beginning of that string there is this voltage value, which is stored in the variable V1, and then there's this temperature value stored variable T1, and in here we are putting those two values together inside that one string called G, and then in here we are giving that string to our UI side. And almost the last command here is that's the name of the HTML file that contains our graphical UI. So this is the name of the file that contains the HTML and JavaScript program or code to create the user interface. This side here was only the communication part between the button and the user interface, and in here we are servicing, we are giving that file when the browser will make the asking the get method. And here we define that what is the main part of the program. And here's one important thing. This is the port number. When we asking browser to show the UI, we will give the IP number and then this port number following the IP number to show that you could also let this off and use the default 8000 or 80. But in this exercise we are using this port number that is needed to be right in the browser side. So now we have went through also this Python code to run this MQTT functionality and the interact between the user interface in the Raspberry Pi.